Yes, welcome to the International Congress on Human-Computer Interaction, Optimization and Robotic Application. Due to COVID-19, we are holding our symposium virtually. I hope this epidemic will end as soon as possible. Yes, let's start the session. First paper belongs to Stide Duraj. Are you ready for your presentation? Mr. Stide Duraj, are you ready for your presentation? Your voice is very low. Okay. Mr. Stide Duraj, can you hear me? Mr. Stide Duraj, can you hear me? Are you ready for your presentation? Okay. Tvestelina Milenova, are you ready?
Yes, hello.
Okay. You can start if you want.
Okay, let me just share my screen.
Okay.
Just a second. Yes. Okay.
Please, you have 10 minutes.
Okay. Do you see my screen?
Yes.
Okay, thank you. Hello, my name is Svetlana Mladenova, and the first paper I'm going to present you is an analysis of the KNN classifier distance metrics for Bulgarian fake news detection. Well, the fake news problem is not new, but despite this and the accepted term for fake news, there's still not an exact formulated definition for fake news. It can be said that fake news has existed since news as a term, but it has not been very active since, but it has been very active since the US election in 2016, and with the development of social networks and the internet as whole. Attempts to define this term have been made by many researchers. What our given definitions of fake news have in common is that they have two main characteristics. First, they are deliberately and verifiably untrue, and second, they are intended to mislead the reader. One of the reasons for the appearance of such large amount of fake news is that in recent years, people spent a lot of time communicating with each other on social networks, and especially in the last year, since they have no other choice. The detection and classification of fake news on social media, and not only in social media and research, has been become an area of exceptional research interest. Google Scholar search term for the term fake news detection returned almost 5,500 searches. And the figure on the left shows how the number of Scopus publications with fake news detection keyword increases, and the figure on the right shows the increase of the Google searches of the term fake news. The goal of our publication of our research is to examine the different results obtained in the process of training a model for classification of fake news from Bulgarian Facebook pages. Why Bulgarian? Well, the research on fake news detections, there's quite a lot of research, but the research on Bulgarian, specifically Bulgarian Facebook pages, is quite limited. For the purpose of detecting fake news and clickbait posts in social media, machine learning algorithm is trained. And since the most popular and widely used social media in Bulgaria is Facebook, the data that is being used for the training of the algorithm is scraped exclusively from Facebook. The data set of the news consists of features such as post title, post description, number of likes, shares, comments, of course, date of creation, and a Boolean value, a Boolean flag for an image. All of the news posts in the dataset are manually classified, resulting in 355 false news and 832 reliable news, truth. It should be noted that the sources of the publications are not taken into consideration. Some of the most notable features used for the training of the model included the number of exclamation marks in the news headline. Around 26% of the false news had one or more than one exclamation mark in its headline, while less than 1% of the reliable news has it. It proven to be a good character for the detection of fake news. Another interesting feature was a Boolean flag showing if the headline was completed or was ending mid-sentence. 56% of the false headlines were completed, while around 96, almost 100% of the reliable news were ending with whole sentences. The so-called urgent words were another feature that proved to be valuable. These words intend to directly affect the emotional state of the readers and encourage them to click on the post and read the whole article. Here, there are some examples of such words, such urgent words: horror, shocking, sensation, nightmare. And around 90% of the false news contained at least one urgent word, while the percent for the reliable news is again less than 1%. The chosen machine learning algorithm is, as we already said, k nearest neighbors. And the four distance metrics are the Euclidean metric, the Manhattan distance metric, Minkowski metric, and the Chebyshev distance metric. And the reason why these four metrics were chosen is that they are predefined in the Python library scikit, and we wanted to test them. While training the models, we've tested entry scalar options, also predefined in the library. The standard scalar, the robust scalar, and min-max scalar. The results with the three scalar options are presented here. And all of the training is done with cross-validation, and the diagrams here show the accuracy scores of all of our trained models. The K parameter ranges from 1 to 45. The best result for the min-max scalar, here on the left, are achieved with the Manhattan distance, K neighbors 44, and accuracy of 82.6%. When using the robust scalar over here, the model should achieve best results with the Chebyshev distance matrix with 34 neighbors, and achieved accuracy, the highest accuracy of all our tests, accuracy of 83%, 0.5. The standard scalar down achieved best results with the Euclidean distance, 32 neighbors, and the accuracy of 82.8%. In conclusion, we can say that our research observes the impact of the distance different distance metrics that they have on the KNN classifier, and several steps are being performed while training the model with the fake news datasets, such as scraping the data from the Bulgarian Facebook pages, data pre-processing, feature engineering, feature selection, engineering of the features I presented earlier, scaling of the data with three different scaling methods, training every KNN classifier with every distance metric and every scaling method. And in the end, the results are analyzed. Thank you for your attention. And if you have questions, I'm ready to answer.
Okay, the participant, do you have any question for this presentation? Okay, you can start your second presentation.
Okay, just a second. Okay, my second presentation is also analysis, but this time of the user experience in a web-based university staff's publication management system. However, we know that we all know that academic work is usually accompanied by routine and time-consuming administrative paperwork, such as annual reports, accreditation procedures, and so others. Typically, these documents are prepared manually by a series of iterations between faculty deans, department heads, academic staff, Most of the time, these situations include sending an email with one's list of publications and citations, and that email being forwarded between many people. This process can be simplified with the help of a centralized, digitalized, web-based publication management system that stores all of the publication activity of the university. In that way, every member of the university have a profile and can manage their publications from it. The University of VROOM2 relies on this kind of publication system since 2012. And in 2020, we decided to give the system a major upgrade, including a new modern-looking interface and some key functionalities, new functionalities. The screenshots on the right are actually screenshots from the new system. It also has some mobile version. The goal of our study is to analyze the user's behavior and detect potential issues after the redesign. And ultimately, our goal is to further improve the system if it proved that it's needed. Since the system can be described as a specific task-oriented system, it's programmed by members of the Computer System and Technologies department of the university. It does not use any templates, and that gave us the flexibility to build in code snippets that helped us collect various data, which we further used in our research. The features extracted from the data include the total length of every session calculated by the stamps of the first and the last session. After calculating the session's lengths, we've observed around 700 sessions with only one event, meaning that the visitor of the systems have clicked on an element and have stopped interacting with the system. These 0 sessions were removed from the dataset since they were not available for us at this point. It should be noted that the whole dataset consists of both logged-in users and guest users. And when a user has logged in the system, we are able to take more actions, such as if the user has updated his score and Scopus number of citations, which is one of the new functionalities. Some other metrics that can be calculated are the average number of events per session, the total number of sessions per user group, and also the number of double events per session, which I'll explain in a bit. This is a sample of the data that we were collecting and we were extracting. We have the flag for logged in user, the session length in seconds. This is actually, the second row is actually a 0 session, which has only one event, one click of a URL or something. The number of double events per session, the date, also the time, not shown here. And if the user is logged in the system, we can see the academic degree of the user. We also have that. For every session, we have the event path of the session. The first, the second, the third example here. We are able to collect this event path for every session, regardless walked in or not. And this is actually a sequence of clicked interface elements in the order as they have been clicked. Some of the interface elements that we were observing were buttons, drop-down lists, URLs, input fields. We've coded them with T for a table, A for href for URL, and the number, increasing number of the button. The double events, the so-called double events, are all of the sequentially clicked interface elements in a session. If we look at the example of event path, we can see that in this session, the user has clicked multiple times on an element as shown here, and as well, the next two events are also double events. The number of these double events and their frequency can be valuable information, as it can point to potential problems with the interface or the hardware, as we'll see in the next few slides. The raw number of unique sessions is almost 7,000, excuse me, collected in the span of 5 months. From this number, the number of sessions belonging to the administrators are removed, and the remaining number of unique sessions is 6,879. Number of zero sessions, 770. 3,000, more than 3,000 sessions with double events. And the maximum number of events per session is 300 events, 300 clicks. And the mean number of events per session is 13.5. The users in the system can be described as follows. Professors, which are the oldest group of users, around 8%. Associate professors includes the all full-time and part-time associated professors in the university, 26%. Principal assistants, all of them have their PhDs and are waiting to become associated professors. They're interested in having more publications, participating in projects, and having their profiles up to date. Assistant professors are a relatively small group of users, 6%. They either have received a PhD degree or are in the process of getting one. The PhD students is by far the largest group, 40%, usually young users, which are in the process of working toward a PhD degree and thus having their profiles in the system updated. This group is more positive about interface changes as well. Others are members of this group are part-time lecturers that do not have any academic degree, 0.7% of all. The following figure shows the number of events and double events per day for the span of the whole 5 months. Since the beginning of the year, the release of the new system, up to mid-May. Several peaks are clearly visible. The release of the new version of the system is announced via an email in the last days of January, and that explains the first peak of users' action over here. The second most visible peak is in the second half, as we can say it, of the system's life. It is interesting the fact that there is quite a large number of double events, which could hint that around this time, the users had some difficulties while working with the system. However, after further investigation of the web server's logs, we were able to detect that the reason for this high percentage of double events is not due to users' inability to work with the system. and more to the fact that it could be due to some hardware or software failure. Here we can see the distribution of the number of events and double events as well per user's group. The principal assistants are generating the most number of events, followed by the PhD students. That can be due to the fact that these two groups of users are interested in having their profiles in the system updated, up to date, and are willing to sacrifice their time in order to update their profiles. It should be noted that here the group other consists both of the user group other and also of guests of the systems, the users who are not logged in. Even though the principal assistants and the PhD students are the ones that are spending the most time in the system, the associated professors and the professors are the ones that are having highest number of average number of sessions. They are focused on their work, frequent visitors of the system, but they are pretty, they know how to use the system and are pretty confident in using it. The following figure shows the distribution of the average number of updates of the scientific data per user group. We have Google Scholar and Scopus updates linked with the academic profiles. And as expected, the professors and associated professors are the ones that have highest number of publications and are frequently logging into the system in order to update their number of citations. Also, the option for updating one's profile from Scopus is somehow more popular than the option of Google Scholar, of updating Google Scholar citations. Here, the blue line shows the work intensity of the system, the events, in the first month of its release, while the orange shows the last month. Also, as expected, at the beginning of the first month, there is quite a lot of activity which gradually decreases over time. In contrast, in the last month, the work intensity is more or less constant, having somehow regular peaks when academic staff, scientists have been forced to update their profiles, their list of publications, and of course, update their number of citations. An interesting factor to look into was the three most clicked sequential events for the first and last month. The most common sequence of events is the same for both the first and last month. Presented here, the first most click for first month and the first more for the last month, or here. The sequence starts with the clicking of an URL from the main navigation part of the system, followed by a series of events that lead the user to a list of lecturers filtered by a department the user has chosen. Currently, the second most common operation after queries for selected lectures by faculty is the updating of the scientific data. This sequence over here. The user walks in, clicks the login button, enters one's credentials, clicks the login button. After that, he or she is redirected to his or her dashboard. And after that, the user clicks the button for update of Google Scholar citations, followed by the button for update for Scopus citations. This is one of the new functions of the updated application of the updated system, and the fact that it's used so frequently means that the user likes it and it's quite useful. In conclusion, the analysis of the user's behavior shows that in the first month of the release of the new version, the users were confused, needed some time to adjust and find their way throughout the system. However, with the passage of time, they started to feel more at ease with it, the new functionalities, the new interface, and the figures and the tables in our considerations are showing that even though there are some places that can be enhanced, the new interface has not made it difficult for the users to work with the system. On the contrary, actually, it gave them new opportunities to show their work. And the users have started to use the system more efficiently and to its full capabilities. Thank you for your time. And if you have any questions, I'll answer them.
Thanks for your presentation. Yes, dear participant, do you have any question about Tvetilina's second presentation? Okay. Thank you again. Mr. Stide Duraj.
Yes, can you hear me? Hello, can you hear me?
Yes.
Okay, thank you.
Okay. Please start your presentation.
I have to upload or to make a share
You
screen?
have 10 minutes, please.
Okay. Do you see my screen?
No, yet. Yes, we can see.
Okay, hello, I am Sidit Dure. I'm going to present our paper titled Adopting Drone Technology in Mathematical Education. I and my colleague, Lekpep Kolay and Gerald Hoja, worked on this paper. Here is a little overview with the framework of dronology in education in technological aspect, pedagogical aspect, space aspect, mathematics for drones, and conclusions. The proposed framework is a framework of dronology, which is an active learning ecosystem that links all three aspects: technological aspect, pedagogical aspect, and space aspect, which are encouraged and enabled by each other. Drones are unmanned aerial devices and they can be controlled remotely. They have 3 levels of autonomy. Reactive autonomy, where drones can react according to the environment and avoiding obstacles and coordinate with moving objects. Sensory motor autonomy, where drones can perform high-level human commands as moving according to GPS. Cognitive autonomy, where drones are capable of simultaneous localization and mapping, object and human recognition, planning, and learning as well. Technological aspect. The educational affordance of a small autonomous drone can be classified into three categories. Video shooting based on active tracing, which refers to a video taken by the drone while it's tracing an object or location. Video shooting based on gestures, which is accomplished by using local onboard cameras on drones and machine vision techniques. Video shooting based on controllers. This is the common form of video shooting. The controller is connected via wireless signals and to a mobile phone or tablet to visualize video shooting. Here there are some types of drones for education, size, models, and also level applications. Pedagogical aspect. Integrating drone technology in and out of the classroom has a lot of advantages. Develop deep understanding, motivation and engagement, technical knowledge and skills, and also critical thinking. Soft skills development such as teamwork, students self-control their work, potential for developing sequence skill, potential for developing spatial visualization skills, and also debate. Develop deep understanding. Using drones improves the ability to understand individual concepts as well as relate many concepts at once, leading to further thoughts and the creation of new concepts. Motivation and engagement. By incorporating drones into students' tasks, has the potential to increase inspiration and engagement, increases their interest in the subject, while also including the element of fun. Technical knowledge and skills. Using drones for educational purposes will improve knowledge, learning and creativity, life and job skills, media and technology skills. Critical thinking. Drones allow students to be motivated to improve problem-solving skills, interpretation, imagination, and critical think skills. Soft skills development such as teamwork. With drones, teamwork can also be used as a pedagogical method. Students self-control their work. A student attempting to place a satellite into a stationary orbit can double-check his or her answer by gazing back at the Earth from the satellite to verify if the satellite remains the place. Potential for developing sequence skills. The sequences capacities shown through the use of building blocks demonstrated the basic mathematical codes by which children view the environment. Potential for developing spatial visualization skills. Using drones in education can include three-dimensional learning opportunities, similarly of the three-dimensional interactive software. Debate. Drones provide the perfect background for such a methodology because they are dealing with a real-life problem. Space aspects. Physical learning spaces or places. Physical learning environments can be divided into two categories: structured, teacher-centered education, unstructured, as example, collaborative learning, social learning, and self-learning. The mathematics for drones, the mathematic topics that make the drone work, and drone as an object that can teach mathematics. Some mathematical topics where the drone can be used are flight planning and trigonometry, Pythagoras theorem, division and addition, the language of differential equation, position and velocity in 2 dimensions, matrices and vectors, traveling salesman problem on steroids. This simulation can be performed in an open environment where dimensions are measured, illustrated in figure. The draw starts from a fixed point with known dimension in relation to those of the environment. You can measure the coordinates of the base from where the drone starts, then its destination coordinates. Another item is the measurement of the angle from the base to the destination. Knowing the speed of the drone, we can measure the flight time. The language of differential equation, position, and velocity. Two simulations are used: a flying simulator, in which the user directs the drone's flying path. The students must finish a skeletal simulation. For the second simulation, students can explain the flight in differential equation. We will use the letters P and D to represent the drone's location and the destination location respectively. Students can provide the following differential equation. Matrices and vectors. Drones can be controlled by an iOS or Android device. These devices can tell where they are and how are they being handled thanks to an electronic compass and the 3-axis accelerometer. The forward direction of the drone is determined by the angle at which the front camera is aimed. If a downward-looking camera takes an aerial snapshot while the drone is flying level, then a transformation of the form transforms the coordinates xy and x2 on the image to coordinates y1 and y2 on the ground as following equations. Drones as an object that can teach mathematics. Arguments that can be addressed. Explore from geometric point of view the basic design of the drone. Identify simple geometry concepts shown in the interpreted in the body of and function of the drone. Make references to math or science principles. Understand 3D and the use of geometry in drone architecture and technology. Plan and build 2D and 3D model of drone. As seen in the figure, different length and the concepts can be used. Measured, example, length B, distance from the teacher to a student. Students should now have two sides and an angle after using the protector to find C. To find the missing side C, use the law of cosine. Students should now be able to identify three sides as well as an angle. To build and proportional and solve for missing angles, use the law of sinus. Figures such as cones and cylinders can be created. Their surfaces and volumes can be found. Conclusions. The use of drones in mathematics teaching has many advantages, both for the teacher and the student, and should be considered more seriously for inclusion in educational curricula. Because of its potential, the use of drones should be considered as an alternative teaching strategy for learning environments where it can produce more effective learning than traditional ones. Drones can play an important role in engaging and motivating learners with attributes of being confident, creative, active, and informed. Content knowledge can be reinforced, and there are opportunities to build interactive and collaborative activities by actively participating in them. A learning-centered, inquiry-based learning environment can be created. One can address real-world problems and improve the critical thinking and reasoning in the learning process. Finally, we suggest 3 recommendations. Challenge-based learning could be more suitable and could yield other education possibilities of drone in the field of mathematics. Further, explore techniques for integrating drone into technology, into mathematics, teaching and learning. So thank you for your attention.
Okay, thank you for your presentation. Dear participant, do you have any question about this article? Okay, thank you again. Dear Wasan Salman, are you ready for your presentation?
Yes, I'm here.
Okay. If you want, you can start your presentation.
Okay. Okay.
Dear Wasan Salman, are you ready for your presentation?
Yes. I did 1 minute.
Okay.
My screen show?
No,
You show my screen?
no,
No?
yes. Please try again.
Mhm.
Dear Wasan Salman, if you want, you can be next.
One minute, please.
Okay.
I think I have a problem. Hello, everybody. Good afternoon. My name is Wasan. The title of my presentation is Analysis of the Traditional Voting System and Transition to the Online Voting System in the Republic of Iraq.
Please, we cannot see your screen.
One minute, please.
You can use share screen command below the Zoom meeting screen.
Hello, everybody. You can show my screen?
Yes.
The title of my presentation is Analysis of the Traditional Voting System and Transition to the Online Voting System in the Republic of Iraq. The main objectives is analyze the existing voting system and the main problems associated with its functioning in the Republic of Iraq. Tasks are analysis of the adopted voting system in the Republic of Iraq and analysis of the application of operating algorithms, Baylor and Binalo in the electronic voting system. Voting is a tool used by a voter to fairly express their opinion in election. Electronic voting system is a remote system that uses the internet, mobile computers, and smartphones to enable voters to vote in election. The main advantage of using electronic voting system is that voters can easily open websites, software, or application on their computers or smartphones to vote anytime and anywhere via internet. In 2005, in Iraq began the first democratic election. The main faction, Independent High Electoral Commission of Iraq, are creating and updating a voter registration, regulation of registration and certification of parties for participation in election, announcement and certification of election results. The major challenges faced by Electoral Commission are intimidation of Electoral Commission employees or voters, falsification, undermining the secrecy of voting, theft or destruction of voting boxes, changing votes. The system consisting of 329 seats. Women must make up at least 25% of the members of parliament. Voting is optional. Legitimate voters has Iraqi citizenship, age at least 18 years, registered in the list of voters. Legitimate candidates have Iraqi citizenship, age at least 30 years. The technology was used in the elections through biometric registration and verification. Automated voter registration is the process of registering voters using biometric information and subsequently using this data to remove duplication from the voter list. For the first time, the technology was used to calculate the results and transmit the results from the polling station to the Electoral Commission vote counting centers on election day. What are the basic rules for election day? Polling station open from 7 a.m. until 6 p.m. Voters were assigned to polling centers based on updated voter data during the voter registration period. Each polling station have a polling station voter verification device, a copy of list to confirm the voter identity, and electronic counting, sorting, and result transmission devices. Each voter who wished to vote signed the voter list to casting a ballot. Indelible ink on voters' index figures also used as safeguard against possible multiple voting. What are the steps for voting? There are 4 steps for voting. First, the polling center queue control check voter hand for indelible ink and ensures voters have electronic or biometric voter cards. Second, election staff identify voters using the electronic voter verification device by scanning voter card and scanning the ballot queue response code. Third, the voter sign the paper voter list and the ballot issued provides a bullet and basic guidance on voiding. The last step is casting the bullet into the electronic voiding, counting and transmitting device, and dipping the voiders figure in interval ink. The main disadvantages of the existing system are to register a voider's biometric and personal data. They must go to the polling stations. The voiders use paper bullets for voting. When used electronic device, it shows the following disadvantages: vulnerability to hacking, the possibility of falsifying the results of voting, and slowing down the electoral process. To eliminate the shortcoming and improve this system, it is necessary to switch to online voting system. The Baylor crypto system is a symmetric algorithm for public key cryptography. Using it in voting system allows you to be anonymous and guarantee the privacy of voters. Allows you to encrypt the votes and store them on the server in encrypted form. After the end of the vote, you can decrypt the results of the vote and announce the winners. Advantage: the counting procedure is very simple. Votes cannot be counted before they are cast. Disadvantage: easy to some attacks. The crypto system is a symmetric algorithm for public key cryptography. Using it in voting system allows you to be anonymous and guarantee the privacy of voters. Allows you to encrypt the votes and store them on the server in encrypted form. After the end of the vote, you can decrypt the results of the vote and announce the winners. Advantage: its homomorphic properties are used for vote counting effectively. Disadvantage is more complex and computational, more time consuming. The voters receive a ballot and public key from election commission and encrypted their ballot with the public key. After that, voters send their encrypted ballot to the server. The server processes an encrypted ballot and send the result to the election commission. The election commission uses a secret key to decrypt the cryptogram and announce the winner of the election. The use of biometric registration and verification in election is one of the most important steps in the transition to online voting. The main disadvantage of this system are: it is not a secure system, can't falsification the results, and the electoral process is very slowly. To improve security in this system, we suggest using a symmetric encryption algorithm to store the votes in encrypted form and calculate them. It is used in the voting system will protect votes from manipulation and fraud, ensure their privacy, efficiency, and speed up the voting process. Thank you all for listening to my presentation.
Thanks for your presentation. Dear participants, do you have any questions about this article? Okay. Thank you again.
Thank you.
Dear Victor Nivago, are you ready for your presentation? Dear Victor. Okay. Dear Shahla Alieva, are you ready for your presentation?
Hello, can you hear me?
Yes.
Hello, can you hear me?
Yes, we can hear.
Okay. Okay. I'm ready for my presentation, if you don't
Okay.
mind.
If you want, you can start your presentation.
All right. Can you see my screen?
Yes.
All right. Good day, everyone. My name is Victor, and I'm here to present a research titled Customer Churn Prediction for Business Intelligence using Machine Learning. This research was done by my professor and I.
Please, you have at most 10 minutes, okay?
Sure. During the course of this presentation, we'll walk through the introduction, and we'll define the problem and objective of the research, and we'll take a look at such terms as business intelligence, data mining, and machine learning, trying to find out the relationship between them. We'll look at the proposed model, we'll look at the implementation and the results from implementation, and we'll have a little discussion and conclusion. Now, the telecom industry is very profitable, and that's why we see a lot of businessmen going into telecoms. Recently, it's also characterized by big data arising from day-to-day activities from customers. Now, as a service delivery business, which means that they provide service or services, customers are prized possessions, not just in the telecoms industry. Any industry that delivers service prizes their customers. And as such, they always come up with strategies to either get more customers or retain their customers. Now, the word churn is an industry word, and it simply means losing a customer to a competitor, and customers could churn for different reasons. They are categorized into voluntary and involuntary. The customers could churn because customer service for the company is poor, or probably the customer moved to a different location and that company doesn't have coverage there, and he just switches to a competitor. So that's involuntary. Now, the word customer retention management is talking about how companies retain their customers. They use tricks, they give them offers, and lots more. Why? Because it is cost effective to retain a customer than trying to get new ones. So the objective of this study is to develop an efficient machine learning model to help telecom firms overcome the problem of losing their customers, whereby they're able to predict a customer who is likely to churn by studying the customer's behavior and patterns using the data available to them. Now, machine learning is an integral part of both business intelligence and data mining. Business intelligence is simply a combination of systems used to invent solutions and map out strategies in a company. And data mining is simply the process of making meaning and raising solutions out of data. So the picture on your left shows the stages or the systems that make up business intelligence, while that on the right shows you the process of data mining. From each of the processes in business intelligence, something is done. From transaction support system, data is collected and stored. From transaction support system up to management information system or decision support system, that whole process could be seen as data mining, because when you look on your right, what goes on through these different systems, through these three systems, is translated into data mining. And in data mining, you have machine learning. Now, here is a block diagram of the proposed model that was used to solve this problem. After getting the data sets, you load them onto the Python library, and then exploratory data analysis was done, data wrangling was done before building the functions that would be used to implement the different machine learning algorithms. The data set was obtained from cargo.com, and the data set contained 7,044 instances, which translates to customers with 22 features. These features could be seen as the variables such as age, duration of stay, what kind of subscription they have, and lots more. The data set included Boolean, string, and numerical data, And all these were normalized. Data wrangling was performed so that we could use the data effectively. We chose a test training ratio of 25 to 75% to ensure cross-validation across the data set. Now, during the exploratory data analysis, we found out that so many patterns could not be unraveled. Why? Because the variables are just too much. And so here comes the efficiency of machine learning. Such techniques as support vector machines, multi-layer perceptron, and deep neural networks. Now, using support vector machines, we employed 3 of the kernels available. Kernels can be seen as a window, or let's say an optimizer to optimize a process. And for each of the SVM kernels, we've used a C value of 1 and regularization value of 2. The chart below shows the performance of all kernels, with the sigmoid kernel reporting poorly and the polynomial kernel having the highest accuracy. Now, with multi-layer perceptron, we've optimized it by tuning such hyperparameters such as batch size, number of iterations, number of layers, number of hidden layers. Now, for stochastic gradient descent optimizer, it performed better by giving it the liberty of choosing an optimal batch size for itself, and also increasing the number of hidden layers gave better results. So from the chart, you could see that when you switch the batch size to auto, as much as tuning other hyperparameters, the accuracy increased. With LBFGS optimizer, we could see that it performed best by adding more layers and increasing the number of iterations while reducing the batch size. Now with Adam optimizer, it performed better by adding more layers as well as increasing the batch size and number of iterations. Well, some of you might be asking, why number of layers and number of hidden layers? Number of hidden layers is also number of neurons. Now, implementing neural networks with Adam optimization. We've employed ReLU activation function simply because it is best suited for backpropagation method of gradient descent. Learning rate was set at 0.1, and beta 1 and beta 2 values were set at 0.9 and 0.99. Beta 1 and beta 2 values were used when employing the Adam optimization method. Adam simply means adaptive moment estimation, and it's a blend of, that's a mixture of root mean square propagation and stochastic gradient descent with momentum. Now, by employing Adam using 10 epochs, the algorithm scored 99% accuracy. This is an overview of all the results from the different techniques that were used. And we could see that Adam here scored the best, Adam with neural networks. In conclusion, the use of some algorithms are limited as a result of big data. So when trying to employ a certain kind of machine learning algorithm, you should take into consideration the kind of data that you're handling, because some techniques are limited to certain size of data, but the performance of neural networks cannot be overemphasized regardless of the size of the data. Now, future contributions to this work would include ensemble learning. And what is that? It's simply a combination of multiple algorithms such that the output from one algorithm serves as the input for the next algorithm. So let's say the output from support vector machines serves as an input for multi-layer perceptron. That is simply ensemble learning. Thank you very much for your attention, and any question is welcome.
Thanks for your presentation. Dear participants, do you have any question about this article? Okay, no, no question. Thank you again,
Thank you.
dear Victor. Shahla Alieva, dear Shahla Alieva, are you ready for your presentation?
Hello, yes, I'm ready.
Okay, you can start
1
if you
minute,
want.
please.
Okay.
Hello there. Thanks for inviting me today. I'm Shahla Alieva, lecturer, Azerbaijan Technical University, Department Computer Technology and Cybersecurity. The Internet of Things and cloud technology have been in development for more than a decade. The rapid development of new technology in the modern era has increased the possibility of introduces IoT and cloud technologies in various fields of activity, but at the same time, the dramatic increase in the number of connection devices implement IoT makes it necessary to take into account the concern and risk associated with their security. Our research investigated the problem that can arise in the cloud and IoT technologies is exciting infrastructure as well as the future development of the cloud and IoT with the use of blockchain technology to solve the problems. As we know, each new technology normally brings about new security threats, and this regress along with the advantages provided by concepts such as cloud computing, IoT, smart home, smart city, which have recently become widespread. We should also keep in the problems of information security that may arise with their use. Thus, using blockchain technology, it's possible to implement as a cybersecurity solution in particular, thus increasing privacy and integrity of information that will provide a variety of security service over P2P-based distribution architecture. This service offered by cloud computing, blockchain, and IoT technologies allow organizations to build their business processes more efficiently. In other words, these three technologies are sought to enable organizations to do more while spending less time and labor. However, in the technical, economical, organizational, and legal problems created by these emergent technologies are disintegrated. They hinder and applications of these technologies. Such problems may arise for a variety of reasons, such as specific of system and professional skills currently used by the organization, the exciting legal framework, the legal status of the organizations, and other technologies. Is a modern era thought system before blockchain technology created by serious infrastructure as a as an infrastructure and market worth billions of dollars. These systems have been studied for a long time, becomes one of the areas of serious development in a way cloud technology was the first technological solution to move away from centralization. More recently, this technology has created the need for wired network connections for the implementation and use the daily operations of status in individuals and companies. At the same time, such problems as server room maintenance, constant security staffing, power supply, variation, and regular updates greatly clear this process. Thus, companies that moved their servers and could begin to carry their operations this direction faster. Blockchain technology has offered user reliable and inalienable data network thanks to distributed decentralization network system similar to the cloud. In this regard, it is in correction to evaluations blockchain and cloud technology as two separated concepts. Also, each is an essential system, its own right. Evaluations them together can give users great perspectives in terms of security. Thanks to an advanced blockchain technology, our device can enable secure end-to-end messaging system that is security in the IoT network. Only people who can communicate and read message to device joining the IoT network will be able to benefit from mutual digital signature and smart contract between them without a third-party authorization to enable messaging exchange. Blockchain technology can provide more advanced security environment compared to central database security. In blockchain technology, each block in the chain and is constantly tracking is the list of records linked to provide blocks using the cryptographic hash functions. It is also a distributed block that keeps record of transactions and can prevent distortion. Blockchain is fully managed over the network and is designed by prevent accidental interference. In terms of management, it allows preventing data-oriented threats and attacks. These advantages make it possible to use blockchain technology various, including cloud and IoT technologies. Our devices are data generation only and could not be considered as nodes in the blockchain, making the integration of blockchain in the IoT very poor. We think that is necessary to leverage this solution toward data integration and better performance. As a figure we saw, the system architecture is composed of 3 layers of showing first layer is related to patient. This second layer is a layer of the outer layer, and so this is the higher layer or the cloud provided layer. We can say it. We can say it. Okay. Study shows that blockchain technology can provide the desired and sought after connection of IoT technologies in terms of privacy and security. The system provides a significant saving in the industry and tracking billions of connection devices and activating a transaction and providing coordination between devices as a distributed architecture result in more flexible peripheral elementing depends on a single system. Considering above, it is possible to list various adventure using blockchain platform. Platform for IoT. First, the decentralization, open and cryptographic nature of blockchain technology allows users to trust each other and to transact between parties when second autonomous systems and devices interact with each other. Use the blockchain technology whose operations and exposed to potential security risks enable our record decision made at transfer simple, cost-effective, and permanent ways. Third, information transfer sections take place between multi-type networks managed by many organizations. To complete this work, multi-performance test recording, mining time, difficulty variance, and blockchain size should be achieved, which will help with future statement in this domain. Finally, what is important for the future of this technology and this process in particular is to implement this architecture in real system and continue to evaluation of performance. Thank you for attention.
Thank you for your presentation. Dear participant, do you have any question about this article? No question. Okay, dear Mandana Fasulnaki, are you ready for your presentation?
Yeah.
Okay, you can start if you want.
Okay. Can you see my screen?
Yes.
Okay.
Okay.
My name is Mandana Fasulnaki. I'm a master's student in computer engineering at Istanbul Technical University. I will today talk about different methods for automatic speaker identification and comparing their performances. Also, I will talk about my proposed architecture. So human voice is considered as a biometric like fingerprint, iris, DNA, face. But the problem is that unlike static features like fingerprint, voice is constantly changing during speaking, and there is not a known pattern to be recognized to discriminate human voices based on their speech signals. So for developing automatic speaker identification, we register different people's voices to the system, and we train a model. And in the future, the model can predict the when we provide a test segment, the model can attribute it to one of the speakers. In this paper, we focused on text-independent identification, which means that there is no constraint or limit on what is being told during enrollment and test. And also it's a closed set identification, which means that all the test speech segments belong to one of the speakers, to the already seen speakers. In the future, since 1960s, many researchers were focused on this problem. In 1992, a Gaussian mixture model, universal background model, was proposed for automatic speaker identification, which is a clustering algorithm that finds the parameters of the distribution of subpopulation in a whole population. And it is trained with expectation maximization algorithm. We train a universal background model on a large pool of speakers, and then we adapt the parameters of UBM to each individual speaker. But this method has a problem with environmental noise and the number of speakers. When the number of speakers are increased, the performance drops. This is one of the methods, one of the traditional methods.
Sorry, we can see your first page of your presentation.
Oh, okay. Can you see now?
Yes.
Okay, I talked here.
Okay.
I talked about text independent identification, and then yeah, Gaussian mixture model. Here you can see, we have normal distributed data, and we find the parameters of these distributions. For addressing the problem of GMM-UBM, joint factor analysis and I-vector was proposed that decompose the signal into speaker-dependent and speaker-independent components. Then we have deep learning approaches like convolutional neural networks, which are originally designed for image classification, but they're adapted to speaker identification in different publications. Also, we have deep metric learnings, Siamese networks, and triplet networks, which is based on increasing the distance between instances from different classes. Also, we have the X-vector approach, which is single fixed size vectors extracted from time delay neural networks or factorized time delay neural networks, and then classified with PLDA or neural networks. These methods require the minimum of 3 seconds for an accurate identification. In this paper, we are focused on 1 second segments. So here's the general idea. We enroll speakers with their voices, and then we pre-process and extract features. Then we train the model and test it. When we have a test segment, we can find the identity of that speech segment. So this is the input audio. We apply pre-emphasis to increase signal to noise ratio. Also, we frame the input signal. Here you can see this is the raw data, and we removed unvoiced segments. Then we frame each segment with 25 millisecond window, and we have 15 milliseconds overlap in framing. So we achieve these small frames. Then we apply Hanning window on each frame to smooth the signal. And then we extract the features or MFCC, mel frequency capsular coefficients. We apply fast Fourier transform, and we compute the power or magnitude to achieve spectrogram. Then we apply mel filter bank to spectrogram. Mel filter bank is mostly commonly used in signal processing for speech signals. And when we applied this filter bank, we achieved MFCC. So here I will talk about my proposed architecture. We talked about GMM-UBM, and we have FTDNN. Here is the architecture of FTDNN, and we have a conventional CNN to compare the performance, and we evaluate the models with accuracy metric. So in my proposed architecture, I, instead of using square small kernels for convolution, because to capture the temporal nature of speech, I use large rectangular kernels that covers all the features of consecutive frames in the first layer. So here in the first layer, we capture the temporal nature. Then we have one-dimensional layers to extract a fixed size embedding, and then this embedding is classified using fully connected layers with steep connections. I applied dropouts, large dropouts after all layers, which significantly improves the performance. Also, with heuristic search, I selected sigmoid and softmax activation functions, and categorical cross entropy is our last function. Adam optimizer with and trained for 50 epochs. This is the details I talked about. So we have 2 data sets. One of them is gathered by us from a call center natural conversation of customers with call center agents in Turkish. Also, this data set has limited data. It has 4 hours for 411 speakers. Sampled at 8 kilohertz, and is a low quality data set actually from natural real life conditions. The other data set is Libri speech, which is gathered from audiobooks. It is a public data set in English and is clean and aligned speech instances that are sampled at 16 kilohertz. It has 100 hours for 251 speakers. So I used 13 MFCCs. For 1 second segments, we have 100 frames. So the input size is 13 by 100. The deep learning methods were developed with TensorFlow, Keras, and PyTorch, and trained on NVIDIA Tesla K80. Also, GMM-UBM was developed with Python, and I used 124 components for UBM and adapted the parameters using map estimation. So here is the division. So for call center dataset, we have 3 speech instances with the average of 3 seconds for each speaker. And for Libri speech, we have 10 speech instances with the average of 10 to 15 seconds. So when we compare the performances, we can see on Libri speech dataset, we have high accuracy, but the proposed architecture achieved the highest accuracy compared to other state-of-the-art methods. But so here we can see the convergence of our model. We can see the loss plot and accuracy plot. We can see that we achieve over 90% accuracy in 10th epoch. On the other hand, on call center dataset, we can see that GMM-UBM performs better compared to other deep learning methods because of the lack of data. When we compare the performance of GMM-UBM on different, when we have different number of speakers, we can see, when we have about 50 speakers, accuracy is relatively high, but when the number of speakers are increased, the accuracy decreases. Also here we can compare the methods based on the training time. You can see the proposed CNN trained for 2.5 hours, FTDN for 57 hours, and conventional CNN for 180 hours. So we can see it's efficient algorithm here. So yeah, the proposed CNN outperformed other state-of-the-art deep learning methods on Libri speech with 99.5% top 1 accuracy and 99.8 top 5 accuracy. Also, the number of parameters is 4.1 million for 1 second identification and 11 million for 3 second setup, which is very low compared to other deep learning convolutional neural networks. And we saw that GMM UBM outperforms deep learning methods, and currently this proposed method is being trained on Vox Celeb dataset with large number of speakers and in various conditions and a large intersection variability, and we are achieving a high accuracy on this dataset also. So thank you for your attention. If you have any questions, I can answer.
Thanks for your presentation. Dear participant, do you have any question about the article? Okay, thank you again. All participants are completed their presentation. Thank you very much. I want to end the session, but I suggest you to attend the special session, which will start shortly at 4 o'clock. I wish you success. See you in other symposium we organize. Okay.
Thank you very much.
Thank you.
Thank you. Thank you.
Thank you very much.